You get any feed on that now?
You live?
Yeah. Oh. Yes.
Got it.
We're right in the middle of prime time.
All right, we do got it. All right.
Hello, hello. Hey, Brian. How's it going, everybody? So we're charging a battery right now using. Actually, I want to stop this. I want to show you this rotor. We got the shaft right on the rotor this time, so the shaft is spinning with the rotor. That's awesome. I like it like that too. Just don't do it very often. That's a perfect fit hole for the shaft. It's a 10 millimeter shaft, 10 millimeter hole, fit right in there, like perfect. So it's, like one of those boomerangs that you would throw. It's 100% PLA, glow in the dark PLA. I'm gonna try and get it to glow real quick. It's not dark enough yet. But it's sweet, man. It glows in the dark. Awesome. So I'm gonna turn it back on and get charging on the battery again. And then I'm gonna try and run kind of like a closed loop system with this coil. I know it's not gonna run right, but I'm gonna get some measurements on it anyway. So the technical aspects of the motor here, it's a tri-filer coil, and I got the 18 gauge and the 20 gauge in series to run for the drive. And then a 32 gauge trigger coil, and that can run at 12 volts really easily, 500 milliamps max. Well, there goes 600, but I think 600 is as high as it goes. Now, I don't think it goes that fast, but it generates pretty well. Let's see here. We want to center that pretty much out right there on top of the coil. That should give us the best rotation and the lowest amp draw. But yeah, I think it moves pretty good for it being on the shaft rotation. I don't have ceramic bearings, and I don't have a vertical maglev of any kind, so it's kind of dependent on the bearings in the stands. I got two bearings in each stand. That's kind of holding it up and allowing it to spin. Right now, I think the potentiometer is all the way open. We can get it to charge faster though.
We got a request. Can you stop the motor again?
Yeah. Let me center it real quick. It's not right. Let me get it right. That's better. Okay, what do we want to see? Anything in particular?
We will wait for a response. Mike does, welcome in.
Hey, Mike. How's it hanging? I decided I got bored and I wanted. This is actually a perfect circle with a few chunks taken out of it. So, with no further ado, I think I'm going to get it cranked again.
I'm a computer engineer, but I gotta ask you, cause I'm into electricity and all that. Can we turn this thing, same kind of motor, into a compressor? And bear with me, man, I'm not really deep into this stuff yet.
Yeah, I think we can do that, and I think we can turn it into a water pump. We can turn it into a compressor. We can turn it into a cold compressor. Something that like is good for a refrigerator. We just need to add the right components to it. All right, are we good? I had to open up the potentiometer because it's like it works best at this end of it. So we can add a little bit of resistance once we get it started, but we shouldn't start with a bunch. No way, it won't even get started.
It says very cool, thank you.
You're welcome. All right, we'll start it at 9 and move it up to 12 real fast. So at the 12 volt system, we got 0.6 max amps taken. So like 600 milliamps, and it fluxes between 400 and 600. So
Can it fix dead batteries?
I think it's doing that right now. I mean, I'm not sure. I mean, we could hook it up to a dead one right now and find out. Let me do that. But yeah, a system like this is supposed to be able to do that. I know it'll send energy through it, but will it maintain a charge? I'm skeptical. Oh man, this is probably not gonna work. I really don't want to be doing this part right now.
Oh, the dead battery.
No, just the lack of length on my cords right now.
Ah, the slack.
Yeah, it's not any fun working with cords that aren't long enough. All right, so we got the output. I'm running it through a cat bank. I don't know if we should do that. So, and this is a whack battery. You can tell by the reading we're getting from it. You can see the reading. I'm not sure you can see it. Let me move this over. And then let me plug it in. To jack up the power real quick so we don't run out of power. All right, let's turn it on, see what happens. I say it goes up real fast, it goes up real fast. That's what I say happens. God, it's really annoying. Okay, here we go. We're gonna fix this after this test. Oh, it's already overloaded. So I don't know if this will do it. It might. But it says 36 volts in the battery. I know that's wrong. But it is a good load. It's a good load because our SSG light is not on. Oh. Maybe it was not good. I gotta change this. I'm caught up. My wires are caught up. Bear with me while I untangle this. Yeah, it was totally covering up the monitor here. Oh, I don't think we can have that going on in there. Hold on a second. I wish there was a way I could pause this. Hold on a second. Turn it off. Now. All right, cool. Back to business.
Society of High Sciences is in the house.
Hello, Society. High Sciences. All right, let's turn it on, see what we get. So the voltage is going down, I think, like not steadily, but variably it's going down. And I think that's a good thing considering that it's so high. I mean, all I have going for me right now is the SSG with gen mode. So if that isn't going to be able to do it, then it's not going to be done tonight.
I saw this motor, if you developed it so it can charge batteries fast with the same performance, I think it's gonna start a revolution in battery. Because if you keep charging batteries like that, instead of lasting just 1 year, they could last 5 years.
Charging them this way? Yeah. I think that's right. I think that you know, the way it's built and what it's built with is going to determine how many times you're able to charge it. Either way, that's how I see it. I mean, I don't know. I don't know exactly how it works. I've only been using batteries for a short time.
William and Darren are asking, what are we doing?
Currently, we're trying to revitalize this dead battery, and it was dead to the tune of like 7.7 volts. I've been charging it for 2 minutes, and it's at 28.7, so it's definitely broken. I don't know how it's gonna. We'd have to test and see if it runs anything.
And then describe the pulse motor real quick.
Yeah, let me stop it so you can see the rotor I'm working with. It's a 120 degree, 1 inch cube, the neodymium magnet cubes. I got 3 of those in this rotor. It's it's a circle. It doesn't look like a circle, but it's totally a circle because of I made it a circle and then I removed some parts from it. So
Darren says amazing.
and then once we get it moving, you'll see what I mean. It's a 100% circle. It's not anything short of a circle. Really cool
Was it hard?
to make.
Yeah.
Not really, and I might have made one thing different. I might have given it an extra 1/8 of an inch. So that one end would be capped off, because right now I've got both sides of it taped, and I think the only reason the magnets haven't flown out is because the forces are actually helping it stay in. This way the forces are actually working with me than against me.
Any improvements from society?
There's some differences. I would say that the main difference is that the drive is, I've hooked the drives and the trifilar together. So we got the 18 and the 20 gauge in one drive. And then I'd say that the shaft is connected to the rotor now. So I can put a fan on there. I can hook a whatever on there, a lathe. It's probably not fast enough for that, but
And then is it 120 degrees?
yeah, it's 120 degree 3 magnet cubes. I think the main, improvement is that it's 100% PLA, and it's really solid, and it's also at the same time less material than the other rotor that I have, which is the black one.
Society says he likes this one.
Oh, I'm so far I'm loving it. You see how it's a circle now.
Aha, says nice thingamajig.
It's
Spelled correctly, phonetically correct.
Thank you.
Darren says awesome, really cool project. Thank you.
Thank you. I can't wait to print a fan for me to hook to this thing and see if it can actually pull some wind. I haven't been able to test any of my rotors that way because they've been the other way. It's just the wheel spinning on the shaft, and now the shaft is spinning with the wheel, and I have more opportunity to like do different experiments. And I like how nicely that fit in there. Like, that was a perfect fit. I needed to use a mallet, but it's like bam. And then if I put it like straight on, you can see that this thing is like a nice print. And with how flat it is, very nice print.
Kenny says the hamster's gone.
Yeah. I mean, with the two drive coils connected, it is a little bit slower and less responsive than if I just had the 18 gauge or the 20 gauge separate. But it also allows me to turn up the juice without there being any problem with like over amperage or anything like that.
Michael asked, what's the end goal? What are you going for?
Right now, I'm just charging a battery. This one, the end goal was to allow me to equip a fan and start pushing different type of load. Um, so I've got this particular model. You know, I've got the shaft equipped so it can do that.
Darren, subscribe.
Thank you.
Spinny mega ball. Turtle scoop.
Turtle.
Oh, and then Fausto comes in and says the hamster has got some spinning heads. Okay. We have can you give us, can you explain one more time?
Yeah, I'll give you another rundown. Let me make sure I got everything in the shot here so that you know what I'm talking about. Here, let's back it out a little bit. All right, you have the SSG with Gen mode circuit. That's using this coil, which is an 18 gauge, 20 gauge, and 32 gauge trifilar coil. And it's using that coil to run this motor. The motor is hooked directly to the shaft. I'm so excited about that. I normally don't do it that way. And it's turning out like perfectly smooth and aligned, and everything works very well. And the shaft is spinning. If that's any measure of torque, I don't know. I mean, I was grabbing it pretty hard, not too hard. And that's, I stopped it, but, it was kind of difficult to stop by grabbing the shaft.
Turtle Scoop says, I love when machines do not have a purpose. It just does stuff.
Yeah, and that's what do you want to hear?
And then Michael said, sine waves?
Sine waves?
I guess, question mark.
Yeah, I mean, I could hook up my oscilloscope, but there's not really anything interesting going on with the waves. I don't have anything picking up waves, really. I got the drive coil, which I can hook it up to, and I will.
And then our purposes are experimentation through curiosity. I think that would be the best way to explain purpose.
Okay, yeah, purpose is curiosity of experimentation and experimentation through curiosity, which perpetuates itself. This thing isn't going to look the same tomorrow.
Society asked, timed single coil pulse motor?
Yeah, I would say it's definitely a single coil timed pulse motor. There's only one coil, one drive coil that is, and one trigger coil. So I would say that's accurate. It's a bifilar. Although it is a trifilar, I've got the two hooked together, like I said. So it's a bifilar where the drive is twice as long as the trigger.
What are the next steps?
Well, I'm going to hook this oscilloscope up to the drive strands as best I can. I need to probably turn it off, would probably be the best idea. And then I need to hook it up right. And let's check our battery's final reading. after running it all that time from 7.76, looks like 10.9, and it's probably going to continue to drop, but oh, we can do the hook it to the output, but I think it's going to go divert to what the output is hooked up to. So it's not going to give the standard output reading. It's going to give the reading of what it's connected to, which is the cap bank, the AC side. But we're gonna check it out anyway. Oh man! All right, we got this. We want to turn it like that. We want to turn this on. And we want to turn our oscilloscope on. Bingo. Now let's run it up. Let's see what happens. This is connected to the output of the SSG with load. So I don't understand why it's like that. Here, let's try doing this. Nope, that's not it either. You saw the SSG light go on when I disconnected the load, right? So this is not going to give us our sine wave reading that we're looking for, that's for sure. Let's see if we scroll in. Ah, so we got a wave, but it's like, it's run through some caps here. Holy shit. Sorry. I'm going to turn that off and reposition that.
King Bowl said another copper coil.
No. Nope, that would mean another stand. And another, no. I have tons of them though. Just not for this build. Yeah, if we go radial again and horizontal instead of vertical, I'll definitely get another coil in here. You know what I mean. As soon as we get it off the top, off of this, and I have to make a special base for that because it's got a shaft sticking through it, so it's got to be able to, you know, that's a lot of work to actually put another copper coil on there.
Yeah.
But what I will do is I will change this. I think. Is my screwdriver here yet? Thanks, bro. Good deal. All right, so I'm going to unscrew the 20 gauge and just screw in the 18, and that's going to go crazy on my amp draw, but we'll have something to get a sine reading off of. And we'll read the 20 gauge strand. With the oscilloscope. And that should give us some pretty interesting readings. Alright. Okay, that's in. These now can go red. We'll go here.
Michael says the solution is more beat with 2 E's. No idea.
Nor. Okay, yeah, I didn't know we had a problem, but of course the solution is definitely going to be beat.
Hallelujah says, so what's going on here? Oh, he said beer. Not beat, beer.
Oh, okay.
And Brian said the solution is always 42.
All right, we're gonna go 6 volts in. Yeah, you see that? That's an awesome oscilloscope reading. Okay, so we're gonna go in. And we're gonna go here.
Jake asked how much volts can you get?
Right now, the peak to peak is only 26 volts. But that is off the trifilar strand. Let's see what AC voltage we're getting instead of that. Yeah. We're getting about 3 volts AC, and it's only at 6.5 volts in. So let's turn that up.
Hallelujah as some sort of electrical magnet.
Yes. So we're going to end up with about 5 volts AC on the trifilar strand. So when it's not hooked up to anything, it's not connected to any load except for the scope here.
And do we, what is the frequency? Do we have that?
Yes, we can check that out. Let me get that real quick.
Lewis says that multimeter looks awesome.
Exit frequency, right?
Yeah.
Alright, so frequency on the trifilar strand is 143.1, 0.2, 0.3. It's increasing because the speed hasn't leveled out yet. 146, 147, roughly 150 hertz. So it's pretty slow, and I mean, there's a lot of friction in this build. I mean, without any question, there's a lot of friction in this build. My other build is a lot faster than this one is, but I wanted to explore the possibilities of having the shaft that's connected to the rotor, which is of course what is slowing it down. Because I don't have honestly, I don't have enough money to get 4 ceramic bearings of that size. I don't have, it's not worth it to me. I think this,
Attach a flywheel to it.
I think this is working. Yeah, I get to attach a flywheel, a fan, you know, whatever. A flywheel would be interesting. At least, you know, a PLA print that's 100%, a 100% PLA print circle. That'd be a flywheel enough for me. And then maybe put a couple magnets in it that are equally spaced.
And then did you read out the frequency, the kilohertz?
Yeah, it's on there right now. Right now it's down some. It's 1.3 because I've been holding on to the shaft. 140 hertz, 140.6. It's 140 going up. 139, 142. You know, 140 would be the average number.
Magnetize the base and float the rod.
Yeah, I'm not doing a maglev right now.
Trim the shaft to a shorter length from Jonathan.
I think that shaft is made out of something that I'm not gonna
Be able to cut through
saw through
with our equipment.
with what I got. I mean, I do have a hacksaw, and I'll probably be able to do it, but that material is not like soft like iron. It's steel. I'm not gonna do that. I like the ideas though, and I've thought of them myself. Actually, quite a few of your ideas have been floating around in my head, and I'm like, you know, I'm probably gonna hear some of this tonight.
18 likes, thank y'all.
Really appreciate it, cause they're great ideas, man. Having the shorter shaft, but yeah, I don't know. With the material that I have, I think it's good the way it is because if I shorten the shaft, then what I'm using to keep it in the center are these couplers. You can see them spinning, and they're attached to the shaft, and there's friction there too. Because when it gets going, it'll lean to one side, and that coupler's there to prevent it from moving out of the center. So you'll get friction there too. And I mean, I'm just making statements of fact right now. I have no desire or passion really to make too many more improvements. I mean, if anything, I would make stands to go underneath the stands that are already there, just to increase the height by a little bit less than these, what do they call, shivs? I think they're called shivs. Shanks? No, shivs. The little, you know, pieces of wood, they're like little slivers of wood. I put two of them together to give me the accurate height. See, that's how I work it, man. I mean, the best I could do really is to print another, you know, thing like those.
They're shims.
Shims.
Thank you, Jonathan.
Thanks, Jonathan. God, I put out two very inappropriate words there.
Welcome in, nobody.
So I got, hey, nobody. I think I know who you are. Sweet. Welcome. Long time no see.
Boss says it's a giant fidget spinner.
It is. It's shaped like a fidget spinner. That's exactly what I would call it. But it's so well balanced that it's like it's barely shaking anything right now. I mean, there's a little bit because those shims are uneven. And the table's uneven, but the build is very sturdy. I mean, the most, you know, logical, obvious change that I would make might be to drop the rotor, get in between the height that these are right now, so it would go down a little bit, but still be above, so where it wouldn't knock. We got, seriously, there's about a half an inch, almost a half an inch of space there. Because there's a lot of room. And we could increase the torque and speed probably a lot by just decreasing the amount of space there is in the air gap.
20 likes.
Thank you, thank you. Oh, and oh, yeah, 100% PLA, 100%. That's not the way you want to stop it. You want to stop it like that.
Oh, wow. Color the sides so a picture appears as it turns.
Yeah, I've heard that one before, and that's like a, I seriously got to sit down with the academia and figure out how to do that.
The spinning art. We can do spirals and really
Because
cool
seriously, when you spin this, all you're gonna see is a circle. So it's got to be. I don't know.
Well, yeah, the surface, there's not much surface area because of the design.
Yeah, and there's not much surface area. So I mean, what you see is a circle that you can see through. You get a solid circle in the middle, and then everything else you can see through. But what I really want to do, I cut out the end of the here so the magnet would stick out. There wouldn't be any plastic yoking it. So this is really, the design is good for what it is. It does catch a little bit of wind, but it is circular actually, so it doesn't catch a tremendous amount of wind. Funny enough, and it looks like it would catch a bunch, but it really doesn't. Actually, I'm going to do a specific test right now with me actually looking for it. We're going to do a wind test because I'm gonna hook a fan up to this beast once I print it out. So there's a draft. I mean, it's nothing major. You would expect way more just from the shape of it. And there's nothing on the sides. Nothing on the sides. It's perfectly like flat on the sides. But there's a little bit of draft in the front. So yeah, that's natural. I don't know. I mean, if you stare at it for a long time, you'll see minor imperfections in that little interior part. That little there's like a dark circle on the outside, and then there's this light transparent circle on the inside. Translucent, my bad. It's a translucent circle because you can see through it, but you can see that it's there. But this translucent lighter circle, you can see like changes in its size. So that might be from the tape. I don't know. Might be from but I mean, like it's perfectly round. There's no like, I don't know. I get into thinking about that stuff a lot because I made so many of these.
Sometimes it appears to be going backwards.
Well, that's good. That means it's going pretty fast. But I'll show you the one. I'm not going to set it up, but I'll show you why it moves so much better. Alright, I got two ceramic bearings in the one that I just put up here. I got to readjust the camera so you can see it. You can see it. That's pretty good. It's a solid black disc with 120s on it. Oh yeah, that's not a good example. Huh. That's all right, but you get it though. There's ceramic bearings in this, and they're rolling on the bearings, so it gets going pretty fast. I tried hooking up a tack strip, but you know it didn't give me an accurate reading. I'd say it goes between like 1500 and 2000 RPMs.
So how much energy is it spending?
Let me see real quick. The way it's hooked up currently, with just the 18 gauge strand hooked up for the drive, say about 12 watts. It's a little less than 12 watts, but it's about 12 watts. So it's 12.2 volts and 1 amp. 1.1 amps. It's a very, very expensive coil. And it's as low as it's going to go on the potentiometer, man. There's nothing lower than what it's on right now. I mean, what I'm saying is, if I move it the other way, it's going to cost more. And it's all the way the other way. So this is where I got to the point where it was like, okay. But I know what the reason is because my coil is so small and it's so fat that it draws a lot of energy even at the most minimum rating. But when I hook them together, when I get the 12 point, the 18 and the 20 gauge together, it's pretty cheap. The highest it goes is 600 milliamps.
600 milliamps.
But we wanted to get the reading on the scope here, our sine wave, or
What gauge is the coil?
the coil is an 18 gauge coil with a 32 gauge trigger. And then it's got a trifilar strand of 20 gauge, which I'm about to hook back up into the drive. All right, there we go. There's a good reading. Pretty sweet. And there's 3 magnets, and there's 1, 2, 3, maybe, is it 4 for a complete cycle? I think it's 4. Because the first one's got to connect 2 for the cycle to be finished, I guess.
You try driving the 18 and trigger your,
Huh?
says you should try driving the 18 and trigger the 20.
Whoa.
You got a huh for that one, boss? Huh?
Yeah, man, you gotta be a little bit more, I could probably do it, but you gotta be a little bit more crystal than that.
How many times can you catch an EMF wave? That's from Brian.
Burgess?
Yeah.
How many times can I catch an EMF wave?
I'm
With
guessing
what?
this might be a pun.
Oh.
But I don't know. He's always got great comments.
But I'm taking it, you want me to switch out the 18 gauge for the 20 gauge as a drive, right? Boss, correct? Not connect them, but just change them. I've tried using the 20 gauge as a trigger and it does not work. So I'm not going to do that. Does not generate enough at any given speed that I can do with my hand to perpetuate motion in the motor. So
Well said.
all right, Tiggs, go play with something, all right?
Mike says it's not enough turns for trigger. Need thinner gauge, more turns.
Yep, I got a 32 gauge in there for a trigger already.
Just needs 2 volts low current.
Yep. I got 32 gauge trigger coil. It doesn't take barely any motion to get going, so I'm good with that.
Legs.
Nice. Congratulations, ladies and gentlemen. We are moving right along. Okay, now I've hooked up the oscilloscope to the 18 gauge now, because this now become the trifiler. And the next thing I want to do is maybe hook up the 20 gauge first in a series combination with the 18 gauge. Hook up the 20 gauge first.
Thank you, Mike.
All right, let's see. Yep, that was good. So we're down to like 12 at 0.5, 0.7 is our max.
Stephen from Ireland.
Hey, Stephen. Hey. That's our 20 gauge strand at 12 volts. And it is drawing, say, like 500 milliamps less. And we're trying to revitalize this battery, and I'm thinking that it's working pretty okay actually.
WH Tech asked, "Are you an inventor?"
No. I am not an inventor. I like to solve problems when I bump into them. So I don't know, maybe I am. But yeah, it's like everything here had a problem that I solved. And I solved it by, it makes it, I don't know, would you say ghetto rigged? Or jerry rigged? Something like that. Yeah, that's the extent of my at least how serious I've taken it so far. So I want to see how much voltage we're getting off that 18 gauge.
NOC from France.
Hello, hello. We're getting 5 AC volts off of the 18 gauge strength. Oh man, my cat was just chewing on the power cord.
That's
Yeah, I had to deal with that real fast. I don't like that.
that's sure cool.
Oh boy. All right, so what I do have here is a DC.
I'll move the camera just a little bit.
Here, let me zoom back out. There you go. But this right here, I can incorporate one of these into the system and we can see what we can do. Of course, I don't want to have this connected in any way directly to a transistor or anything else. There's got to be a diode or something in the way protecting it.
Where is your pot resistance for Boss?
It's a fully open right now. It is at, if I move it the other way, we're going to get a higher cost. So it's all the way open. Let me show you actually. It's all the way to this side. Now if we move it even a little bit, you get way more generation, but I mean, look, we're drawing almost 2 amps now. It's just not worth it to play around with it. And I mean, what really could be happening is that the transistor might be fried, because it'll only work when the resistance is off, basically. So it's fully open. I mean, I guess you get some resistance just for having the pot hooked up, but, and you turn it, and like I said, even just a little bit, immediately we're almost up to 2 amps. But that does sound like there's a problem with the transistor though, doesn't it?
You want to stay just below the humming noise. If it hums, turn it down. From Boss.
That might be it right there.
Mike does says that's possible.
I think that click right there is the most resistance I can have on this thing and have it function. Because I can turn it down more, but then it won't be on at all. I think it's good where it's at. It is on a little bit. I'd say about 100 ohms is where it's at right now. Maybe a little less. Man, I really want to play with the other wheel now, though. Man, that's unfortunate.
Could be the pot making that noise. Resistance varying. Could be a bad pot.
Totally could be a bad pot. But I think with that in mind, I don't know. That would suck. I only got one pot. That's it. That's all I got. But what I can do with that in mind is try and get the sweet spot. I think that this is 100 ohms right here, this one. I'm gonna check it out though real fast. And I'm gonna hook it up and we're gonna see if the pot is the problem.
He said you can static resistor or coil. Or whatever you're doing.
Well, I'm gonna put a resistor in the slot and then we're gonna put the potentiometer on the end. Like it's supposed to be hooked up. This is a 100 ohm resistor, that's perfect.
We have switchwood in the house.
Hello, hello. Let us So I moved the pot all the way over to the end, and then I got these two slots that are open. I'm gonna put this resistor right in there. Did we get it? Okay, so we'll do this, and if the pot is, I don't know, this isn't really going to determine whether the pot's broken or not, but it might smooth everything out a little bit. Yeah, I don't know, the pot does seem to be kind of whack. So there's one more change I gotta make now. I'm gonna take the pot out of the picture for right now. And then if it's the transistor, I'm out of those too, so. All right. Oh, dude, not what I wanted to do. So it is chirping a little bit with 100 ohms, but I think it's pretty good. Do need to get a new pot. Have to get a new pot because that isn't gonna fly. And yeah, well,
Chirping with the resistor means the transistor is going out.
yeah, I would bet.
The flyback will always damage transistor eventually, unless it's redirected.
So there's one thing I'll try. I got a transistor laying right next to it. And it's not really chirping. You know, I think it's a good transistor. It only chirps when it goes slow. So we'll test this one laying right here. And then if it's bad, we'll put this one back in and we'll leave it alone. Might need to get a new keyboard. All right.
figure it would arrest the movement of the flux, that which moves within a container while an event takes place. That's Brian.
Oh yeah?
Peace out, Mike. Thanks for dropping.
So we're at 400 milliamps. That's brilliant. So about 33 volts. A little bit better than the 18 gauge strand, I gotta admit. Awesome. So I just decided to turn the voltage up a little bit since I'm hooked up to a power supply, and well, bam, we got way better readings at 19.6 volts and 800 milliamps.
800 milliamps.
We get about 45 peak to peak.
I found some pretty cool stuff. There's new stuff. And I'll be sure to start it when we start it. So.
All right, cool, man. I'll be right back. Hello, hello. Awesome. So all in all, guys, I think that this rotor is pretty cool and it's got potential beyond the rotor because it's hooked to the shaft. But this rotor right here, it's got speed hands down, beyond measure. And it is totally because the shaft is, it's got the shaft. And it's a tiny coil. It really is. It's I think it's 300 turns of each, so 900 turns altogether. That's not a lot. And the battery looks like it is getting healthier. It's at 10.9 now, and it started off at 7.76, highly fluctuating. So that's awesome. That is good, a good sign. So things that are on the docket for whenever is a potentiometer, maybe a couple potentiometers, maybe some 10-turn pots that are cheap. Copper.
Avram says I'm getting components to build a solid state oscillating generator.
Like a meg, like a motionless.
And then Davis says, I like what I see here.
Thanks, Davis.
What am I looking
Oh, what are you looking at, huh? Well, it's a pulse motor with a vertical setup. It's 120 degrees on the rotor, with 1-inch cube magnets. The coil on the base there is 600 turns of 20 and 18 gauge, and then 300 turn trigger of 32 gauge. So it's basically a bifilar coil. It is a trifilar coil, but yeah, right now I'm using it as a trifilar coil. That's basically it. It runs, it generates. Right now we're revitalizing this battery right here. And currently it is working. It was a busted battery 2 minutes ago, and then right now it looks like it's going to be able to be used again. So that's awesome. But I do think, all in all, since bifilar coil is the way that this SSG is supposed to be set up, that, and attaching the 18 and the 20 together is going to be the ultimate correct answer. That's awesome. With that 100 ohm resistance put in, we're drawing like 400 max milliamps right now. 300. It's not going very fast, but I mean, that's not a big amp draw. I want to drop it down just a little bit, or maybe what we need to do is need to raise the coil up a little bit. Let's see if this is too much. That is cutting it really close. I think that, dang it, gotta be joking. Yeah, let's move it all down a little bit. Maybe this way. Yeah, it's too freaking high. Dang it. Oh man.
How many times do you plan to catch the EMF wave? Right.
I don't know if I've done it the first time yet. Alright.
Shim with paper on one side of the frame feed. That was, you were talking about leveling thing.
Yeah, it's like one hair or two. Oh, was that good? It's still rubbing, but
31 likes.
nice. We're still rubbing.
Melvin says, great job.
Thanks, Melvin. There we go. That's more like it. It is rubbing slightly, a little bit. But it's going way faster than it was without it rubbing.
Is that a portable oscilloscope?
It is indeed.
Josh Holman says, always good content.
Thank you, sir. Heck yeah, thank you. I didn't see that bearing had popped out.
All right, I got a poll going.
Nice.
Asking people if they got pulse motors at home. We got 5 votes with 3 votes as a no.
Cool.
2 votes as a yes.
Does anybody prefer to make their own or buy them? I like both. I like to make my own, and then I like to buy them to see like how I can make mine better, or sometimes to gloat. I don't know. I don't get to gloat very often because it's all kind of rudimentary, basic level design in my mind. It's not anything complicated. Like as soon as you start putting threads and stuff, and you start like making holes with you can screw stuff into, that's another level stuff right there. If you can do that, more power to you. This is just basically putting holes in basic design patterns, and that's basically all it is.
You're zoomed in on the oscilloscope.
Okay.
And he said, thanks for the zoom in.
You're welcome. All right, yeah. So boosting up the coil helped out a tremendous amount. It is knocking though. There's some knocking going on right now. It's just, you know, that fraction of a hair of a centimeter not working out right here. I will, I might make it better, or I might not. I might hook up the other wheel later on. I don't know. Um, yeah, I was just really happy with the way this one turned out because it's all the different shapes and stuff. But when it spins, it's a circle. I mean, it's like a perfect circle. So I consider that a win. There is a draft here, though. Definitely a draft. And I did spin it this way, down. So it looks like it's going up. That's another thing. Can't wait to print a fan that I can clip to this one of these couplers right here. Sweet. Oh wow. Yeah, that other wheel over there. Oh man. We're gonna do it on a different live stream, but it is very fast.
Brian's theorizing that the stickiness in the air contributes to draft. Humidity.
Oh yeah, for sure. You know, there's a hypothesis that says everything from here to inner space is water. They're virtually different variations of water, different levels of moisture, and that we're all that's why we're 95% water. And there's like we think look at ourselves and we're like, there's no way that we're 95% water. And I'm like, well, we move through this water material called air every day, all the time. And yeah, I'd say we are about 95% water.
That sounds nice.
So that's 20 volts in. And that is 800 milliamps, 700 milliamps. Beautiful. Solid. I mean, the shims, I gotta change up the shims, and then it will be a really solid build. Maybe put it on a different table. But the potentiometer took a dump, I'm pretty sure. It's not functioning the way it's supposed to. I need to get a more accurate potentiometer and maybe put this one away for when I got a little bit better idea of what I'm looking for. I need more like a 10 turn potentiometer. So I guess I can get one of those or a handful of those. Awesome. Hold on a second. Turn it down. Yeah, my kids are out there doing something. I had to, hey! I had to ask them to turn it down. He came right in here and started chewing on the power cord again. So what I was actually wanting to do is, since this is all run on trigger, I wanted to hook up the signal generator to it as well, and every time that it pulses, have a higher frequency be pushed through it. I've been told that this can increase torque. So like virtually every time a magnet passes, every time the 140 hertz that this is active, we can send through, 10 kilohertz every time this is active. I want to see something. I want to see the reaction of that. I have no idea how to hook that up currently, but I'm working on it. I think you would hook it up the same way you hook up a pot, kinda. Um, you hook up your positive trigger strand with the red one, and then you hook up your black one to the negative of the drive strand, which will hook it to the universal ground. Man, let's do it. Let's do it. Seems simple enough. Let's give it a shot.
All right, we now have 11 votes and 64% no.
Okay. Good, good. So there are some people that are doing it themselves, just some people that want to see it done. That's awesome. All right.
I think getting part of a transformer coil and running this motor by it would yield some interesting results.
Yeah. Only I don't mess around with MOTs, man. I don't mess around with that.
Belgian subscribe.
I would make my own before I mess around with one of those. Just because that's who I am. I'll make my own first.
Wizard is in the house.
Hey, Wizard. All right, so we'll start the kilohertz.
$35 likes.
All right, here we go. All right, so I'm thinking I might have the black one hooked up on the wrong, because so that didn't work out the way I expected it to. So I'm gonna try switching this.
3333 views. Getting way more likes this time.
Sweet. Nice. 3333. That's awesome. All right.
They're staying longer.
Brilliant.
26 seconds.
There it is. That's what I need. All right. That's awesome, man. We're only drawing 100 milliamps. Oh, wow, dude. Did everybody hear that change? So this is a 1 kilohertz per hertz on the pulse motor. Wow. Definitely a torque increaser. I can see it. I can hear it. Way more,
And that's called the signal generator?
yeah. That's putting in a sine wave at 1 kilohertz. It increases the milliamp draw by 600 though. There's 2 kilohertz. Three kilohertz. I think 2 kilohertz is the number. That one sounds the healthiest to me.
2 kilohertz.
So if you understand what I'm doing here is that every time the magnet activates the trigger strand, it sends 2 kilohertz of frequency through the coil. Oh wow, dude. Almost 11 volts of AC. And look at how slow it's going. That is impressive. .600 hertz, 500 hertz.
Seconds.
That's so cool, man. Because you can turn it off and it'll still function. That's awesome. 100, 200, 300, 400, 500, 600. All run through the SSG. That's awesome, man. That is brilliant. I think 1100 hertz is a pretty good number.
Jerry asked, what is this?
It is a pulse motor. It's got a 10 millimeter shaft, 120-degree magnets on the rotor. The rotor kind of looks like a boomerang. Pretty cool design, I think. But there's something cool about it. You know, we got a 20 gauge drive strand going through the coil. We have an 18 gauge trifilar strand. We have a 32 gauge trigger. But up to that trigger, we have connected a signal generator, which is currently every time the magnet interacts with the coil gets a burst of, right now it's 1100 hertz of frequency sine wave. So it's like every time the coil is on, it gets a burst of 1100 hertz. Man, I'm glad I thought about that. That's awesome.
He said, cool.
That's 1200, 1300, 1400, 1500, 1600, 17. 19 sounds good. Needs to grind a little bit. So I think mainly what it does is it increases the torque because it pulses that signal, you know, a lot faster when it's on than when it's on without it. So this is just one pulse per magnet. The signal generator is off. And seriously, man, I mean, the amp draw is 200 milliamps, which is awesome. But here, we're going to turn up to 100. And we're going to watch the meter here, how rapidly it goes up. It's 200. Oh, man, I think I'm going to do my closed loop system with this. Heck yeah, I think we're going to win with this.
Discovery. That's a good point. Tell how doing one thing can trigger.
Well, I'm just seeing
one-
how, yeah, I'm generating a lot more electricity just by turning up the hertz on the trigger strand, and more electricity generated is always a good thing when you're doing a closed loop system. So this is a kilohertz, 1 kilohertz sine wave. I think that's it, man. 1 kilohertz where it's at. It's almost 11 volts solid, man. That's great. Thanks for the likes, everybody. I really appreciate that.
That might be like, I think 36 was the other.
So, yeah, I think with the combination of the signal generator, we might end up on top here. I mean, that's a lot. Just for changing the hertz, we got 5 more volts, like 5 or 6 more volts coming off the top, and that's a lot. That's a lot. That's not resistance. That's frequency. And I'm pulsing the trigger coil right now. So every time the trigger coil activates, which is when a magnet passes by enough for it to activate the transistor, the frequency gets boosted every time it's on. So 3 times the rotation, it gets a kilohertz. And that's enough to put it up 5.5 volts. That's awesome. I think I could even do it with this rotor. With that kind of output, man. That's awesome. You hear it though. Oh, there's 11. That's 3 kilohertz. You can hear it like every time it like passes over a magnet. You can hear it like. You know what? I'm gonna turn it all the way down to like 1, and let's see what happens. Oh yeah, you can hear it like 1, 2, 3, 4. Yeah.
All right, we got 19 votes now, 68% now.
Okay. That's okay. That's cool. I like that. So I'm gonna look here and see what the frequency is being generated on the bifiler. 56 it looks like.
Harold dropped in and says, "Can you create a time machine?"
I don't know. Maybe.
That's funny. There it is.
There it is, man. There it is.
The time machine.
It's got a couple on-off switches, a little bit of electrical tape, a couple batteries. Voila.
And Brian says, "You are already a time machine." That's a good one, Brian. We are a time machine. I think this guy knows Nikola Tesla personally. Do you like the idea of time travel or not?
Oh, I got my personal opinion about it. I don't know if I have a collective idea on it.
Josh has heard.
Oh yeah. Yeah, man. I mean, I do. I don't think you should go backwards in time, man. I don't think there's a point in the world to go backwards in time. I mean, if you're gonna go back beyond human existence in time, I think that's okay. But if you're going back to like change something, I'm just a big bird to you, man. You need to let the past. You need to let dead dogs lie. That's what it's all about. Going forward, though, I think that might eventually become like an excursion that people will do for money.
Mm-hmm. A business. Yeah.
But going backwards, man, I don't think that's morally incorrect. And I know I'm here saying it, and I'll probably be the first one to go back in time. Like, frick, man.
I just wanted to see that, but then I dropped a wrapper and it was all over.
Yeah, man, because seriously, if you vibrate on frequency and you put your frequency in a place where it wasn't before, you are already messing stuff up. Just by standing there. You don't have to touch anything or talk to anybody. Just by you standing there where you're not supposed to be is messing stuff up. But see, the future's different because it hasn't happened yet. If any of it's real, man, the future hasn't happened yet. I mean, like, if you think you have a choice in the matter at all, the future hasn't happened yet.
Yeah, Brian says, "I think there is only now, past, and the future never existed or can't exist."
That's true. Now is definitely the only time that is relevant. And that goes for everybody. That's the one thing that's true for everybody. Right now is the only time to you that is going to be relevant. And everybody can consider themselves equal on that. You know, they can be rest at ease. We got equality. Yay. On all levels. That, you know, time now. You know, living for the moment. It's not necessarily living for the moment. I mean, don't try to make this a philosophical discussion. It's not really. It's not about living for the moment. It's about the fact that the only time that is really going on ever is the time that you exist in, and that is right now.
Hacker says, what you got?
This here is a pulse motor. I want to slow this down.
All Effects says, nice Ferris wheel.
Thank you, sir. I like to call it the Price is Right wheel. We're going to stop it so we can take a good look at the rotor. I'm really happy with it. It's a 100% print. It's got 3 neodymium cubes in it with these holes. So I made holes so that it's not yoked with the plastic. It's like a little boomerang with 3 equal semicircles removed. It's very well balanced. And currently I have a signal generator hooked up to the trigger, which is awesome. It's got a 10mm shaft. And it's like secured onto the rotor. So I can hook up a fan. I want to print a fan, but I gotta make it. I mean, this one already moves the air a little bit. It doesn't though. It's really phenomenal how you can have big spaces in between like that and have it not move air pretty much at all. I mean, there is a little bit of a breeze, but it's not like you would expect. And it's because you look at it right now, you can see that it's a circle. And the pieces that I removed were removed from a circle. But removing those pieces allowed me to do the 100% PLA print with under 120 meters of material, which is awesome. So, all right, we're going to look at the frequency now when I turn the generator on. Oh, wow, that went way up. Wow, but it's like, it didn't increase in speed that much. So it's obviously a synthetic frequency. Oh, that's so cool. And I'm wondering if that synthetic frequency will carry over to the voltage uh, and make it real voltage instead of synthetic voltage. I don't know if that means anything, synthetic voltage, but I mean, you get like a 400 increase in frequency from running the signal generator through it. See, it's way up there in hertz now. Instead of 140, it's like 560. $2,200. Should I try changing the waveform real quick? And that's the difference between a sine wave and a square wave. Awesome. So thank you everybody for chiming in on the voting. Really appreciate everybody coming in and stopping by. We're all learning as we go here. But really, I'm finding out that running a signal generator along with the trigger coil has its benefits, and we're going to run a closed loop system with the signal generator involved. We're going to see if that changes anything. So, but as for right now, this is Papa Bale signing off. And thank you very much. And peace out. Have a wonderful night. Please subscribe. Bye now.